Get you to take your chairs. We're going to start here in a moment or two. Well, it got quiet enough, but I'll still wait for a few more of you to find your chairs. To refill your coffee cups, I see, is a common practice. Chris, this mic seems to pick me up really well. Can you hear me in the back? All right. I have one of those voices that I can often get away without using a mic, but in a room this size, that would be very foolish. Good morning. My name's Keith Gabert. I'm an agronomy specialist with the Canola Council of Canada for Calgary, North Central Alberta. I'd like to call your attention to the fact that this particular portion of our morning is sponsored by the Manitoba canola growers. This will be the Flea Beetle panel for the next period of time. Jay left me a fairly hard act to follow in that he was on time each and every segment of the day and actually had a question panel and time for it. Apparently that wasn't the case yesterday. I missed that. I'm the insect management lead, so good bugs, bad bugs. I talk to people like Paul and Sarah as part of my job, but I predominantly focus on pest insects because that seems to be the most challenging questions that farmers will throw my way when they phone and want to talk about insects. We've got 4 presenters lined up for you and a Q&A very similar to what we've just had in the last session. So without further ado, I will introduce our first speaker, Dr. Heping Yang, and call him up to the stage. He's a senior science fellow at Bayer Crop Science. His expertise areas include RNAi, technology, a number of different biotech advances for the company. Before that, he worked at the Plant Gene Expression Center, UC Berkeley and USDA. He holds a PhD in Bioscience, and he's going to talk about today RNAi-mediated crop production history, means, and regulations.
Thank you, Keith, and the committee for this opportunity here today. Doesn't advance? Yeah. Yeah, and press. Not on, maybe. Oh, there it goes. All right, so crops cannot run away from harmful situations. It's up to us to do whatever we can to protect the crops. And there are many ways to protect crops, but the focus today is on RNAi mediated crop protection. Maybe one, sorry. Sorry about that. So what is RNAi? In 1988, a group reported Anderson's RNA can suppress this pigment gene in petunia, leading to white flowers. They suspected the RNA duplex play a role. 2 years later, another team found out the sense RNA could also suppress the same gene in the same species, producing white flowers too. They thought DNA methylation may be responsible. Almost 8 years later, Fire and Mello demonstrated double-strand RNA was far more effective than either strand in suppressing genes in nematode. They call the process as RNA interference, or RNAi. In the last 30 years, much progress has made. Now we know RNA-dependent RNA polymerase can convert antisense RNA and sense RNA to double-stranded RNA. The double-stranded RNAs are then chopped into siRNA or microRNA. These small RNA get loaded to RNA-induced silencing complex, guide the complex search for and trigger degradation of target mRNA, or simply block protein translation. RNAi-related mutations supply input to both evolution and conventional breeding. For example, soybean seeds were originally black. The pigment gene got duplicated. Genome rearrangement occurred. The seed coat started to produce small RNA. The pigment gene got silenced in the seed coat. We got golden yellow soybean seeds today. When AGO5, a key gene in RNAi pathway, is no longer functioning, the seed coat stops producing siRNA. The pigment biosynthesis resumes. Then the seeds go back black coat again. So at Bayer, we strive to develop RNAi traits for enhanced crop protection. This is an example of produce protection by RNAi. The antisense RNA introduced to the tomato to suppress the enzyme responsible for fruit softening, leading to increased firmness, better resistance to fungal infection, and longer shelf time. We know this is a RNAi product because we can see the siRNA, but the target mRNA gone in flavor savor. So this is the first biotech fruits approved by FDA for human consumption. The corn rootworm is one of those most destructive pests. Crop rotation, insecticides, and Bt protein are used to control this billion-dollar pest. To develop but each time the insect quickly develop resistance to each of those tactics. To develop a novel mode of action, we introduce a downstream RNA to the plant. That downstream RNA was designed to knock down the SNF7, a gene essential for survival of the pest. In the gut cell, the downstream RNA got chopped into small RNA, leading to death of larvae. So this is RNA-based technology is slower, but a very powerful mode of action. Together with Bt protein, this downstream RNA provides superior protection against the corn rootworm. This product is also an indication of a new direction of pest management, offering diversified, cost-effective options for farmers to protect crops from this horrible insect. So it takes more than 10 years from discovery to commercial launch of a biotech product. The good news is here, the current regulatory framework covers applicable to RNAi crops. So on average, it takes more than almost 7 years to get a global approval for a biotech product. But that doesn't mean, that seems to takes longer for RNAi-based products. In fact, we got global approval for this product, RNA-based products, in just 5 years, way below the average. To create a crops against severe storms, we developed a short corn using microRNA-mediated RNA pathway. So the microRNA designed to lock down 2 GA synthesis genes to lower GA levels primarily in leaf and stem tissues. The stem shorter but thicker and stronger. The plant has better resistance to nodging and green snapping. As you can see from the picture, after a severe storm, most tall plants fell off. The short corn still stood straight. So this product can really save crops from severe weather events. It also gives farmers the full season-long access to the field, allowing application of fertilizer in later season when plants need it the most. And that can improve nitrogen use efficiency and prevent fertilizer runoff. It took just 1 year for USDA to review and approve this product. As a completely different approach, a non-transgenic approach, we have established this BioDirect platform, with which we use double-strand RNA directly to control weeds, pests, pathogen. We can coat the seeds with double-strand RNA, apply double-strand RNA alone, or with traditional pesticides. So as you can see on the right, glyphosate alone couldn't kill all pomer plants, but adding a double-strand RNA effectively kill all the resistant pomer weed. Also, a double-strand RNA significantly reduced damage to canola crops from flea beetles, and another double-strand RNA protected the tomato plants from infection of cucumber virus. In summary, RNAi is a sequence-specific technology. It has a long history of safe use. The transgenic approach provides consistent whole plant and season-long protection. The topical approach can get a product to the market much faster. The current regulatory frameworks cover RNAi products. With this RNAi technology, we can target plant, weed, pest, pathogen genes by using double-strand RNA delivered by transgenes or topical applications to create unique or enhanced traits for crop protection against pests, weeds, pathogen, and severe weather events. With that, I want to thank these individuals and thank you for your time and attention.
Thank you, Heping. Our next speaker is Jeff Bertholet. We'll bring him to the stage. I have a long bio for you, Jeff, that I'm not going to read. For those of you that have been in the industry as long as Jeff or I, Jeff has generally been viewed as the BASF guy. And I'm told he was brave enough to retire and managed to do that for a grand total of, I think, 90 days or less, and now is doing a bit of work with Greenlight Biosciences, and he's going to bring us up to date on some of their activities as it might relate to canola.
Well, thanks Keith. I'm really excited to have the opportunity to talk a bit about Greenlight Bioscience, introduce them to people who may not know who they are, and talk about the RNA applications in agriculture, discuss some of our preliminary work on flea beetles, and I think more importantly, identify some of the opportunities where we're looking for partners to work with to commercialize a product for flea beetles down the road. So Greenlight Bioscience has significant development and testing capabilities. They operate on 3 continents, North America, South America, and Europe, and have done close to 600 field trials to date. They work on, it's hard to take that BSF badge off and put another one on. Work on a whole range of different crops and applications. And the products that are closest to commercialization are primarily insecticides and fungicides and miticides. In addition, to be able to produce sequences very quickly, the company has a lot of expertise in formulation development, and I'll show you a bit later why that's important. And then also the ability to scale up and to commercial levels and produce products very efficiently. I'm glad Dr. Yang went first because I have the How RNA Works for Dummies version up here. So when an insect ingests RNA, it ends up in the cells in the midgut where it produces siRNA, and then that RNA will bind specifically or exactly to the area of mRNA that it was designed for. And then when that happens, the ability for the mRNA to code for protein production is blocked. And so that effectively will eventually end up killing the insect. So I want to talk about some of the benefits of RNA in agriculture, and do that mostly just by quickly introducing the first product that will be commercialized. It's Calantha, which is a product for Colorado potato beetle control. And we're anticipating registration in the US very soon. And so the active ingredient, Ledprona, represents a new mode of action. And so all these benefits that I'm going to talk about for Calantha are typical of RNA products in general. So it represents a new mode of action. It'll be in IRAC group 35. And so these products offer a lot of opportunity for use in an intensive pest management program. They're used at very, very low rates, typically in a foliar formulation, a few grams of active ingredient per liter or per hectare is used. And in the case of Calantha, it inhibits feeding of the larva, and then the pest will eventually die. When you develop an effective formulation that is delivered quickly and the RNA is able to survive and not be degraded by microbes, these products can be very efficacious. And so this is looking at flea beetle or Colorado potato beetle mortality across 40 trials, and you can see that Calantha is performing similar to the commercial standards used in the trials. So because, as Dr. Yang said, that the technology is very specific and targeted, it's very safe, both to applicators, to the crop, and to the environment. It degrades very quickly in the plant, soil, and water. So from from a residue standpoint, and we were talking about residues in the first panel, a product like Canola will have a residue exemption. There's no need for a PHI, and they're simple to apply. They can be tank mixed with other products, so they're very easy for a grower to fit into an IPM program. So switching to what I'm supposed to be talking about is flea beetles. We've done some preliminary work, and I wanted to show the life cycle first, not to go through it, but just to highlight that, you know, populations are very high in the spring, and then as the second generation emerges, they're high later in the summer. And this will become important as I talk about some of the opportunities for research going forward. So the preliminary work we did was lab studies, and we looked at 4 different sequences of RNA, and they were effective. They provided 75 to 90% control, but unfortunately that was after 10 days after application. And so when you consider the high populations and the slow, relatively slow activity, and I should mention these were not formulated RNA sequences. We have some work to do for developing a commercial product for field application. And I hope today that I can talk to a few of you here about potential opportunities for research, because we'd really like to collaborate going forward. And some of the areas we want to look at is speed of activity. So we look at targeting different genes that are maybe more sensitive to RNA. Another potential is to target genes that inhibit feeding of a flea beetle so that you know, it's not damaging the young crop. And combinations with other products like Dr. Yang mentioned. And of course, formulations will be very key in improving speed of activity. So once again, thanks for the opportunity, and look forward to talking with you going forward. And this isn't the best job I can do presenting. I'm just not feeling very well today. So thanks again for the opportunity.
Thanks, Jeff. Our next speaker is Dr. Janet Knodel from North Dakota State University, and she reminded me that there are, in fact, a couple universities in North Dakota, so I had it wrong earlier. Janet's been involved in insect control and IPM strategies for a number of crops, including canola. I've met Janet a number of years ago. I'm happy to say this first time in person. Co-authored more than 600 papers, well-respected entomologist in her field, and unfortunately planning on retiring at some point soon, but we'll benefit from her experience in her talk today.
Thank you, Keith, and it's a pleasure to be here today. I'd like to thank the hospitality of the Canola Council of Canada for bringing me in. First, I'd like to acknowledge all of my collaborators from NDSU and also from the University of Minnesota. Today I'll be presenting just the data from North Dakota. So we do have 3 key production areas in North Dakota, up in the northeast, north central, southwest, and we don't grow as much as you do here in Canada, but we grow 729,000 hectares, and it's valued at $1.3 billion. And we are #1 in the US in canola production. So we have the same 2 species that you struggle with in your canola production, the crucifer flea beetle and the striped flea beetle. And the crucifer flea beetle is our dominant species and still is today, but we are seeing a slight increase in the striped flea beetles. And of course, we're concerned with the damage that the growers face reduce plant stand, reduce growth, uneven maturity, and of course the yield loss. So this study was focused on looking at the insecticide seed treatments that are commercially available and comparing them to see which one is the optimal insecticide seed treatment. So here are the seed treatments that are registered in the US, and I know you have the same ones up here in Canada. So we looked at the single active ingredient that you're familiar with in the neonicotinoid group 4A, thiamethoxam, known as the Helix vibrans, and clothianidin. We'll be looking at Prosper Everglow today, and then there's imidacloprid, which isn't as common anymore. Then there's also some premixes out there, 2 active ingredients that are combined with the neonicotinoids. The diamines, the group 28, cyrantonilapro, Fortenza, or Lumiderm, and then also butanolids, the 4Ds, Buteostart, and that's the newest one that has been on the market for 2 years in the US. So here's our treatment list. We got the fungicide, check, that's like the untreated, and we use the vibrance, which is the fungicide portion in the insecticide seed treatments that we're working with in Helix vibrans. And all of our treatments had the fungicides on, as well as the insecticide. Helix vibrans was at 1,500 milligrams per kilograms, and then we looked at the premix with the Fortenza at the standard rate. Then we had the premix with a foliar insecticide on top called Brigade, which I know you don't have the bifenthrin active ingredient registered for flea beetles up here, but it's probably one of the most common ones used against flea beetles in North Dakota. Then we got Prosper Everglow at 1,400 milligrams per 100 kilograms, and then also the premix with the Lumiderm. And Fortenza and Lumiderm are interchangeable. It's the same active ingredient at a slightly different rate. Then we had the premix with the foliar, and then the same thing with the Buteostart at 625 milligrams per 100 kilograms, and then the premix with the foliar insecticide. So then we have at each population, we have a mixture of crucifers and striped flea beetles, and the ratio kind of varied at the site and year that we looked at. And then also we assessed feeding injury by using a rating system, 0 being no damage, down to 6 being a dead plant, and our current economic threshold for applying foliar insecticides is about 20 to 25% defoliation, and that comes out at a rating about 2.5. And we assessed injury at 3, 7, 10, and 14 days after emergence. So here's some of the data. This shows you on the horizontal axis the treatments. We got the single AI, Helix vibrans, and Prosper Everglow, and then the fungicide check is way over on the right. And then the flea beetle feeding injury is on the vertical axis. So you can see we had significantly lower feeding where we use the insecticide seed treatment single active ingredient compared to the fungicide check. And here where we had the premixes with the Fortenza, Lumiderm, and Buteostart, you can see we also had significantly lower feeding injury compared to the untreated check or fungicide check. And it looks like Buteostart has a little bit lower ratings compared to the Lumiderm and Fortenza. And then where we applied the foliar on top, it's interesting to note that the ratings were a little bit lower. We had economic populations of flea beetles at all of our 3 sites in North Dakota, Langdon in the northeast, Minot in the north central, and Fargo in the southeast. Looking at the yield in the black line there on the top, You can see that all the insecticide seed treatments had significantly higher yield compared to the fungicide check of 1975 kilograms per hectare. So it was significantly different in all treatments. However, the best top yielder was where we had the brigade, the foliar insecticides on top, and this was due to our severe flea beetle feeding pressure. So here, if you're visual learning, I took some pictures here. You can see the fungicide check. The plant stand is reduced. The stand is uneven. The feeding injury is significant. If you look at the Prosper Everglow, you can see the stand is improved slightly. There's still quite a bit of moderate feeding, and the plants are just a little bit larger. If we look at the premixes, where you got the two modes of action and active ingredients, the plants are bigger, the stand has improved, and there's less feeding injury. If you take a look at the Prosper Everglow and the premix Lumiderm and Potato Start with the foliar insecticide brigade on top, you can see we have much larger plants, improved plant stand, and less injury. So here we ran a regression between yield and flea beetle feeding injury to look at the correlation. And you can see, of course, the untreated check, the fungicide alone, had the least yield and most feeding injury. Where we had the single active ingredient, it was 27% higher yield than the untreated check. Premixes was 9.6% higher than the single AI. And the premix plus the foliar had 16% higher than the premix seed treatment and 27% higher. So quickly, just to look at the economics for this for the growers, you can see where we had the foliar on top, the bifenthrin or brigade, we had the highest return on the crop value. We also had a foliar insecticide right side by side next to the seed treatment study, and we didn't get quite as good return with bifenthrin applied once, or at the bottom of the slide there, applied twice at a weekly spacing interval. And then here, if we look at the net return, we take minus all the costs from the additional inputs of 2 active ingredients in a foliar application cost and the insecticide. You can see still we had the highest net return with the foliar on top. And remember, we had economic populations of flea beetles. So for our growers that have both species of flea beetle and the population is high, I'm recommending them to use a premix at least, and then follow up with close scouting and thresholds to see if you need to put on that foliar on top. And then we do see foliar sprays going out more frequently in North Dakota to control flea beetles. We're seeing an extended flight period, and we have mixed populations of flea beetles present. So we may be seeing this becoming more common. So I'd like to acknowledge Jim Johnson, Star Specialty Seeds, Kevin Thorsisness from Bayer Crop Science, Nathan Hagrud from Syngenta Crop Protection, and the Northern Canola Growers Association for funding for this study. And we'll address any questions during the break session. Thank you.
Thank you very much, Janet. That graph is exactly why growers keep chasing flea beetles. Our last speaker in this section is Alejandro Costamagna. He's a professor from the University of Manitoba and has done a large amount of work on flea beetles in Western Canada. His title of his talk is, Can We Manage Flea Beetles Using Plant Density? Alejandro.
Good morning, thank you very much. Thank you for the invitation to allow me to present this work. Going too fast. Okay, first I want to acknowledge all the colleagues that helped to collect all these extensive data set and conduct these studies. So we were interested in see how plant density can be incorporated, so increasing seeding rates can be incorporated into manage flea beetles with our current techniques. The two species have been already introduced, so I'm not going to spend a lot of time. Just to point out, we have two dominant species, crucifer flea beetle, striped flea beetles. In some regions, one is more abundant than the others, but they tend to be present, both of them, across the prairies. Luckily, the life cycle was also covered, so I'm going to just highlight the portion that in the spring where we have these small canola seedlings coming out is where we have the adults of these flea beetle species coming out of overwintering. And that's important for the rationale of using plant density because that means there's a defined limited number of flea beetle adults that can cause the damage. They're not increasing in numbers at that time. If anything, they're dying, those adults. So if we increase the number of plants in our landscapes, then there will be less flea beetles per plant available to damage them. So that's the rationale of increasing plant density. And previous studies done by Lloyd Dostal here in Alberta show that increasing planting seeding rates tend to decrease the damage by flea beetles. And recent work done by Ola Lundin, who presented earlier this morning from Sweden, also show that in their studies. So we conducted a series of trials across the prairies with collaborators from Canada in Lethbridge, in the Peace River region in Alberta, in Saskatoon, and in Caravan in Manitoba. We conducted several trials. We have data from 18 of those trials combined here, and we manipulated plant density with 3 levels. A low level was 3.5 kilograms per hectare, and optimal level was 7 kilograms per hectare, and the high level was 14 kilograms per hectare. We did this in small plots, and we monitor the number of flea beetles with yellow sticky traps put weekly or renew weekly in each plot. We combined that with 4 insecticide management options. The first one is a control, which we just monitor the plots. Then we did a foliar treatment, which was applying foliar insecticide at 25% defoliation, which is the current threshold we have. And we had a seed treatment as the third treatment. We use a product from Syngenta, Fortensa, and Visivio. And then we have a fourth treatment, which was meant to keep the plots free of flea beetles to obtain hopefully close to the maximum yield. And that was done by a foliar spray on a weekly basis independently of the presence of flea beetles. So when we combine that with the 3 plant densities, we obtained 12 treatments, and those were replicated in 4 blocks for each of the trials. So what we did was to analyze all these trials together, and to do that, we standardized the data. That means we subtracted the mean observed per trial and divided by standard deviation. So the graph that you see there on your left, the axis, it's a scale axis. So if it's below 0, means there's a decrease. If it's above 0, means there's an increase over the mean of that trial. So I'm going to go a little bit in details in there. So the first data I'm presenting you is on how these manipulations affected the abundance of flea beetles. And this is more than 2,000 sticky traps that are summarized here. On average, we have close to 100 flea beetles per week in these sticky traps, so that's a number that probably will cause concern to growers and will anticipate losses. And the first treatment we have there, the control. So increasing the density of the plants increase the amount of flea beetles. So they are attractive to these high density plantings. When we apply a foliar treatment, we see a decrease in the number of flea beetles, but the same trend, more flea beetles where we have higher planting densities. Seed treatment, same trend, less number of flea beetles present. And then our flea beetle free also show the same trend. So increasing the number of plants attract more flea beetles to those plots. But the real question is whether the pressure of flea beetle was alleviated. Remember, we have a set number of flea beetles. We offer them more plants. So we would expect to have less flea beetles per plant. So that's what we check next. We divided the abundance on the sticky traps by the number of plants per plot. And we see the opposite pattern. When we have high densities of the plants, then we see less flea beetles per plant in the control, in the foliar. In the seed treatment, we see that for the optimum and high densities, we did not see a reduction in the low density. And then in the flea beetle free treatment, we observe the same. So increasing the plant densities attracted more flea beetles, but not enough to compensate for that higher number of plants. So on average, the pressure tended to decrease. Now, the next thing we look is at defoliation. This is, again, summarized in a big data set. We survey 20 plants per plot per week for the susceptible period. So there's more than 100,000 assessments of defoliation condensed here. On average, we got around 20% defoliation, so not really high numbers. In some regions, we have plots with high defoliation in the control. And what we obtained is that in the control, there was no difference in the increase in plant density, did not result in a decrease of defoliation. It was pretty even. Same for the foliar, there was an overall decrease of defoliation with the foliar treatment, but plant density didn't affect that. And in the flea beetle control, the same. The only treatment that we see that increasing plant density reduces flea beetle defoliation was in the seed treatments, which is indicated there by the different letters. And finally, the thing that most growers care the most is yield. When we analyze the yield, we observe that nothing really matters except plant density. So in the optimum and high density plots, regardless of how we manage flea beetles and the amount of defoliation or anything else, we obtain better yield across all these experiments than in the low planting density. Okay, so just to finish on time, which is we can conclude that flea beetles aggregate to plots with higher plant densities, but that's offset by the more number of plants that we have there. So on average, flea beetles per plant decrease when we increase plant density. We observe that didn't translate into decrease in defoliation, except where we have the seed treatments, where we see the highest decrease in defoliation. And finally, the most important conclusion is that plant yield was increased when we have better plant stands, when we have higher seeding rates, regardless of flea beetles and the management that we did on those plots. So with that, I would like to thank all the colleagues that collaborated in collecting and conducting all these experiments, and Ted Laboom from Syngenta for providing the seeds treated with these insecticides and fungicides. And with that, I'll thank you for your attention.
Thank you very much, Alejandro. I'll bring the other speakers up for a panel discussion. If I can get 30 minutes on the timer, that would be, well, you are at 25 is fine. So as the flea beetle guy for the Canola Council Agronomists, I was happy to have 4 speakers talking about flea beetles, and I wasn't sure if there was any underlying message there other than from Janet, you were going to spray them regardless, and you needed to control them or you were going to see it in your yield. And from Alejandro, it was to have the right number of plants, or more plants would be better. And I think both of those messages fit very well with the management strategy. I've got 2 roving mics for for questions from the audience, and I think we'll start there just to see where your questions go before I start to ask questions that I might have for them.
Got one here, Keith.
Yeah.
What do I need to do? Sorry.
Sorry. Okay. My question is about the pre-existing patent on the RNAi technology, because I think Monsanto, I heard that they have a patent on the technology itself, not on the targets. And is that going to be a limitation for people that wants to apply this technology?
I can take a stab at that. So I started with in October, so this might not be the most complete answer. So I'm not 100% sure. I know, as you said, Monsanto has ownership of the patent, and I don't know if that's being shared with other organizations, but there's also, I think, intellectual property around the formulations that are developed and also scaling up for commercial production. And so I think that's, in Greenlight's case, that's one of their areas of strength. And I can follow up with you maybe with them on a more comprehensive answer later.
Question over here. Boyd Murray.
Hey, this is for Janet. Janet, I'm just wondering, with your flea beetle studies and different seed treatments, did you see any regional differences between kind of the north and south?
This year, it was fairly consistent. We had fairly heavy flea beetle pressures at all 3 sites we tested in North Dakota, although it depended, we were a little bit later due to the weather planting in the north central at Minot. So the flea beetle pressures were a little bit more moderate there. But at Langdon and both Fargo, which is Fargo in the southeast, is not a canola production area, but we seem to have good populations on campus. So yeah, no, it was pretty high to moderate.
Chris.
Yeah, I have a question to go for both Jeffrey and Heping. Looking at the potential of RNAi as a product both for pest management and potential other ideas, say for weed management or manipulating plant growth, is this going to be something that could be commercialized for canola in other areas, specifically on flea beetles, or is there more interest in other ways that it could be implemented?
Yeah, that's a great question. So we know RNAi is a universal natural process. So yeah, we started working from corn because that's the biggest crop for the company. But we do have R&D activities around canola as well. But I just cannot go into details.
Yeah, and to me, I think there's lots of benefits that I tried to highlight for using RNA in agriculture. And we certainly want to continue the work in canola specifically. And one of the areas on my slides that they were on my slides, but I didn't reinforce it, is we were all talking about the high populations in spring. And I think one of the areas we could explore is just population control, either by targeting genes that development genes that impact flea beetle fecundity, or are targeting control of that second wave of flea beetles later in season, so that you're reducing the number of adults overwintering, because I think that's a huge challenge for the insecticides. And I think Janet in the afternoon is going to talk a little bit about, the insecticides being less efficacious, and so I think there's real potential for this in canola.
I have 2 questions. One with the RNAi. I'm trying to understand this from a layman a bit. So what you're telling me, we could have the potential to, say for instance, like an old chemistry like clethodim, you could have group 1 resistance to that. You could add a product to that and maybe tell the wild oat it's no longer resistant to clethodim. Is that Would that be accurate?
Yeah, so I think conventional, traditional pesticides or insecticides are still going to play a role in agriculture, but RNAi provides us with a new approach to some of those challenges we face today. One would be just use this newer technology to control, to help pesticides or insecticides to control insects, or we can also use this RNAi technology to help control weeds. We know there are resistant weeds out there, and you cannot kill by any herbicide sometimes. So by adding dsRNA, we can control those resistant weeds, and kind of also save some motivation for traditional herbicide, because by using multiple mode of action, you can delay or slow down the resistant development, because it's very unlikely you have a weed develop, all of a sudden develop against all different options, different technology. That's the merit.
And my other question is about the flea beetles. Have you seen any correlation to delayed maturity with infection levels? Because where we're from, if you delay that crop, say a week, you could have some troubles on the back end of maturity, just with frost and whatnot. Sometimes you're not worried about it taking the bugs taking the crop, but there is a maturity delay I noticed. But I was wondering if you had any correlation to the infection and the severity versus how much delay in maturity. Do you have any data on that?
That might be a question for Janet. I know when people ask me as a canola council agronomist, have I got that data for damage to the crop, and if it looks like it's been hurt by 2 weeks, what does that do in October? And I don't have a good data set for that. So,
unfortunately, we haven't worked with that aspect.
No, I think we have that data, but we haven't had the chance to look at that. I just show you the first analysis, but yeah, that's something that we hear often, that that's one of the major potential problems of this. So if the crop recovers, maybe delays maturity, so we'll definitely look at that. Thank you.
And in North Dakota, we usually have most of our crop off in August, or early September, so we don't have the frost problems.
We've got a couple questions from online through Marissa.
Yeah, the first one is, do you think that soil moisture can reduce the efficacy of seed treatments in canola? So I'm not sure who wants to take that one.
Okay. Sure. Yes, there is an impact with the environment and insecticide seed treatment efficacy. We've seen, from complaints from growers as well, when the soil is cool and wet, the seed treatments are not as good, and it's probably due to the lack of uptake. The canola plant is not actively growing, so it's not uptaking the toxin into the plant for protection against the flea beetles. So we do see that quite frequently, and that occurs quite a bit in North Dakota. And when that happens, then we need to follow up with insecticide if it gets to be an economic population with a foliar.
We'll go to one at the back of the room.
Yeah, just a question for Heping and Jeff. We talk about the science a lot, but how about the economics to the farmer? Certainly double-stranded RNA, cost of scaling synthesis, and long-term storage is maybe a concern. How close to cost parity do you think you can get to traditional plant protection products?
Yeah, so that's one of those reasons. The most part of my talk is focused on transgenic approach, because it takes time to develop a biotech crop, but for farmers, it doesn't cost much. If you go spray double-strand RNA, it's going to cost lots of money. Yeah, it doesn't take much to kill a bug, but you need to go out to spray over hundreds of thousands of acres. It costs money. That's why a couple of years ago, after acquisition of Bayer, the management did an evaluation and say top approach is not our top priority. And transgenic approach is going to provide consistent and whole plant and seasonal production, and doesn't add much cost to farmer because we sell traits as a package, not a individual mode of action. So I think that's the reason we move on with the transgenic approach.
Yeah, and I think from Greenlight's bioscience perspective, they've figured out how to scale up the products very effectively, and so I think cost of production is low, relatively speaking, and the use rates are extremely low, a few grams, and so I think they understand, or we understand, that the cost to the farmer needs to be competitive for sure.
I have a question that's probably mostly for Alejandro or Janet. Janet, you indicated that you had relatively high pressure. You had no issues getting over the 25% defoliation. And those are the growers that will call us and are concerned. My challenge has always been that I can't tell you who that's going to be in advance. Are we making any, it's outside the scope of your presentation perhaps this morning, but are we making any advances on predicting who needs those seed treatments or who needs those higher seeding rates, or both? Like where are we at predicting flea beetles?
Oh, well, they're unpredictable because they are good flyers and they can fly fairly far. So we haven't been able to. We've looked at populations later with the summer generation that comes out and feeds on the pods, but we couldn't find any relationship there. And I know in Sweden, they're doing some work with suction traps that are run during the field season to predict the population the following spring, and they had some luck with their flea beetles in Sweden. And the paper is recently published here.
Yeah, I agree with that. It's very hard to predict field to field what's going to happen. We have some work done at the landscape scale, and we seem to have some patterns that if you have more canola in the landscape, so at the large scale, then you tend to have lower damage, which is consistent with what we see or we expected to see in the small plots. We have a defined number of flea beetles that it's going to distribute. So if there are more fields, the damage per field should decrease. We tend to see that in the landscape now to know what these fields are going to be, which ones are going to receive less damage. I think we're not yet there.
Thank you. Question from the far side.
Yeah, it's me again. Couple of questions here, I guess, and I guess we're looking at, from one of the presentations, looking at RNAi. Really, this was discovered, I guess, about 25 years ago. We've seen it progress over the past couple decades. What would you say is the greatest barrier currently right now for commercialization? Is it regulatory? Is it an economics calculation there? And then if this is going to be approaching to market, at least in the canola industry, can you give a prediction on when that could be? Are we 3 years away? Are we 20 years away?
Well, in the case of a product like Calantha, it's been submitted for registration in the U.S. and no one is really allowed to talk about timelines, but I would say that the registration is anticipated imminently, and then we will follow that with submission in Canada. And I think Canada's PMRA is often first to register something, but they also will look to the U.S. And I think in this case with this technology, harmonization of approach will be important.
So the transgenic approach is just similar to traditional conventional biotech trees. So it takes about 7 years to get deregulated. Topical approaches take much quicker. On average, maybe 1 to 1.5 year or up to 2 years. Yet, it's time consuming, but economics is there, and that's why it's a part of our portfolio.
If there's no more questions, I'm going to say last call. It looks like we might be ahead of schedule for lunch. I don't have any questions. I was a little surprised at 137,411 observations for Alejandro. That's a lot of tracking flea beetles. I'm pretty sure I've talked to growers that feel they've made that number of observations in a field about flea beetles as well. But I think the challenge still remains that, and Janet's initial response or knee-jerk reaction to the prediction question is we can't seem to predict these flea beetles. So that really is part of the solution that we're going to have to go for, and to be able to predict these insects and time them with climate, and be able to give growers some direction. Because my standard joke, which has been the same for 10 years now with the council, has been that 20% of growers will need significant flea beetle protection, and I just don't know where that's going to be as we go into seeding. So with that, I would like to thank Manitoba canola growers for sponsoring this panel again, and acknowledge that we have a number of great sponsors for this event, particularly BASF and Bayer. A big thank you to Proven Seeds for sponsoring the students you see here today, Alberta Canola, Corteva, High Tech Productions, and SAS Canola. We could not do this event without the support of those sponsors, and others like the Canadian Canola Growers Association, New Seed, Brett Young, DL Seed, Syngenta, Western Grains Research Foundation, and Winfield United. So please give me a round of applause for the speakers and our sponsors for today. And we'll reconvene at 1 after you've had lunch. Thank you.
Hello, I'm Canadian Canola, and I've become somewhat of a global celebrity. Yeah, I'm creating a heck of a lot of jobs for my fellow Canadians.
Hey, thanks, Canola.
But now I'm recognized for being in everything. Yep, cosmetics and lots of innovative industries. The world can't get enough of my sustainable Canadian goodness.
Hey, Canola, over here. My picture. Canola, looks so pretty. Canola, over here.
The butcher, Ryan, he suggested I use sausage in the stuffing.